Hello everyone, and welcome to my first maths video. Today we're going to be solving a partial derivative question using chain rule. Okay, now we first start off with writing the formula for the chain rule, and that would be dw over du. For instance, this one, the formula for this one is dw du, okay? And then we write here dw over dx. The function here is dx. Multiply by dx over du. And then we're going to add that with dw over dy. Multiply by dy over du. Add that with dw over dz. Multiply by dz over du. Okay, so what is this symbol here? It's basically the same thing as derivative. It's a derivative, but of the function of what they give you here. So for instance, we have dw over dx. We write dw dx. And what is that? So we grab this function here, w function. We derive that in respect to x. Let's see. Oh, that's w. I wrote it again. Anyways, so we'll write it again here. dw over dx equals to, scratch this one out. Okay, so what's dw over dx? We differentiate that. Make sure everything you see as a constant, and then make x the variable that you want to derive. Okay, so xy, that'll become x. Y. That's it. We ignore that because it's constant. If it's a constant, it becomes 0. dw dy, we derive in respect to y now. Here it's just going to be x. Finally, dw over dz equals to, we derive ln z. ln z is just going to be 1 over z. Okay, now we have to find the differentiation for dx du, dy du, and dz du. Okay, now where's dx du? These are the functions for it. X equals v squared over u, y equals u plus v, and z equals cosine u. Okay, now when we want to differentiate x, y, and z, they have to be in respect to u. So make everything else a constant and find du. And so this one is going to be negative v squared over u squared. So that's just the partial differentiation in respect to u for x. Dy over du is going to be derive this one in respect to u, so it just becomes u. Finally, we derive z cosine u, and that will just become negative sine u. Okay, now that we found all these differentiations, we just have to sub all of that into dw du. Okay, and we sub every function here into this chain rule formula. Okay, so we see this dw dx, dw dy, and dw dz here. And this one, dx dy, dy dv, dz du. Okay? Now, when we sub all that in, we'll get dw over du equals dw dx. What's that? Y. Multiplied by negative v squared over u squared plus dw dy, so that's x, multiplied by dy du becomes u plus dw over dz, 1 over z, dz over du, negative sine u. Now, we can sub in the y, the v, and the u, and the x. Also here z. So, the y and the x and the z are the original values given in the question. So here x is v squared over u, okay? D3. So y, where's y? U plus v. Put here u plus v. X, v squared over u times u plus 1 over z cosine u multiplied by negative sine u. Okay, before we can sub in the u, we can convert this to tan. So let's get tan u here. U plus v, negative v squared over u squared plus v squared over u plus, sorry, negative, becomes negative. There's a negative here. Tan u. Yep. Now, what we're going to do here is we're going to sub in u and v. Here, they've given us u is negative 1 and v equals 2. So we just sub in u, negative 1, and v, 2. Negative 1 plus 2. Negative 2 squared over 1 squared plus 2 over negative 1, 2 squared right here, times u, which is negative 1, minus tan negative 1. Okay, we can just put this in the calculator and we will get And that will be rough answer. We could put the rough answer here, 1.56, and before that we could put like a what before 10 is, and that is 0 minus 10 negative 1. And that is how you solve partial differentiation.